Astronomers have made a surprising discovery using the James Webb Space Telescope. They have identified the most distant globular clusters ever seen. These clusters are composed of millions of stars and could be the remnants of the first stars to form in the universe. What did James Webb Space Telescope just discover? And how would this discovery impact everything? Stay tuned as we bring you this fascinating discovery by the James Webb. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. The first science quality image taken from NASA's James Webb Space Telescope revealed a fascinating distant galaxy surrounded by dense clusters. These clusters may contain some of the earliest stars in the universe and are located at a distance of 9 billion light-years from Earth. The team of Canadian astronomers focuses on the sparkler, or spark galaxy, because of the unusual appearance of its stretched shape and the compact subjects surrounding it, which look like small reddish yellow blobs. The galaxy is notable for its unusual stretched appearance, but the surrounding objects that inspired the nickname are of considerable scientific importance, as they may be the most distant globular star clusters ever discovered by astronomers. But what are these globular clusters? Globular clusters are groups of ancient stars that have been present since the formation of the galaxy in which they are found. They are important because they can provide information about the earliest stages of galactic evolution. A team of scientists from Canada has examined the compact objects surrounding the sparkler galaxy and found that 5 of them are globular clusters. These clusters may be the oldest ever observed and maybe have existed since the earliest times in the universe. Study co-lead author Karthik G. Liar said it was surprising to find such a unique object so early in the James Webb Space Telescope data, and that most of the flares around the main body of the galaxy are truly massive and ancient stellar systems. This discovery has the potential to provide valuable information about the evolution of the universe and how galaxies and stars formed. According to Liar, thanks to the James Webb Space Telescope image, the team was able to study the sparks at different wavelengths, allowing them to accurately model globular clusters to learn more about their physical characteristics, such as their age and the number of stars they contain. Before the James Webb Space Telescope, it was impossible to date the first stars in distant early galaxies using distant globular clusters. In an interview, study co-author Lamia Molla, an astronomer at the University of Toronto, explained that the goal is to date all objects in the universe, including stars, galaxies, and globular clusters, and to find out when stars began to be born. It is currently believed that there are 150 globular clusters in the Milky Way, although their age is unknown. The discovery of distant and ancient globular clusters could provide valuable clues about the early formation of the universe and help solve some of the biggest mysteries in astrophysics. Compared to younger objects in our galaxy, older globular clusters are more difficult to date and determine their age. The sparkler galaxy, seen as it was 9 billion years ago, is easier to date because the globular clusters around it appear younger at that time. It's like looking at a picture of a baby instead of a picture of an adult to estimate their age. According to astronomer Mola, it is easier to determine the age of a 1-year-old child than the age of a 50 or 55-year-old adult. Astronomers use data from the James Webb Space Telescope NIRISS to confirm the age of globular clusters in the sparkler galaxy. NIRISS detected no oxygen, which is common in young clusters that are in the midst of star formation. To observe the galaxy, James Webb Space Telescope was aided by the Hubble Space Telescope and a phenomenon known as gravitational lensing, which is a useful tool for astronomers thanks to Einstein's general theory of relativity. According to this theory, massive objects bend space-time, which affects the path of light through space, like placing balls of dust on a stretched rubber sheet that becomes more dented the greater the mass present. Nearby objects acting as gravitational lenses can distort and magnify the image of the background object, making it appear much larger. In the case of sparkler galaxy, the gravitational lensing of the SMACS 0723 galaxy cluster distorts its shape and magnifies it enough for the James Webb Telescope to detect it. In addition, some of the surrounding clusters appear to be in multiple locations in the image due to its effect. This observation confirms that the clusters do indeed orbit around the sparkler galaxy. However, astronomers still do not know precisely how much the SMACS 0723 cluster amplifies the image of the galaxy, so they plan to build a better magnification model to get a more accurate estimate. If the magnification of the sparkle galaxy and its clusters can be understood, more precise information about their age and distance from Earth can be obtained. For this reason, the CONEX team will use the James Webb Space Telescope to investigate 5 giant galaxy clusters in the hope of discovering systems similar to the sparkly galaxy. The expectation is that the James Webb Space Telescope ability to observe globular clusters at great distances will encourage more research and searches for similar objects in the future. Astronomers also plan to use the James Webb Space Telescope to investigate distant globular clusters to better understand their evolution. There are 2 main theories about the formation of these objects. One suggests that they are formed during the cosmic dawn, when the universe was in its early stages of star and galaxy formation, while the other theory posits that globular clusters formed mainly during the cosmic midday, when most stars and galaxies were forming. This discovery has had a major impact in our understanding of the universe and has prompted NASA to develop even more powerful telescope than the James Webb Space Telescope to confirm whether our understanding of the Big Bang is correct. Data obtained from Webb's F spectrometer and near-infrared camera have revealed that 4 of the 6 primary galaxies have extreme redshifts, suggesting that Webb is observing them as if they existed 300 to 500 million years after the Big Bang, without heavy elements such as carbon. This is surprising, since the universe is estimated to be 13.8 billion years old, and the existence of these galaxies suggests that we need to revise our understanding of the early universe. This has generated concern in the scientific community, as these new discoveries challenge the current cosmological inflation model and the Big Bang theory, which has some loopholes, such as going against the law of thermodynamics and not having a clear explanation of what caused the Big Bang. In addition, the James Webb Space Telescope is discovering galaxies almost as old as the Big Bang itself, which questions everything we thought we knew about the origins of the universe. According to theoretical physicist Michio Kaku, the discovery of ancient galaxies by the James Webb Space Telescope has called into question everything we knew about the beginning of the universe. Previously, these galaxies were thought to be less developed than the Milky Way, but new findings suggest that we may be missing crucial information. The fact that the telescope has identified 6 galaxies that existed 500 million years after the Big Bang and are up to 10 times larger than the Milky Way raises the question of whether our current theories about the creation of the universe are correct. Kaku explained that it takes billions of years to create a galaxy like the Milky Way, so it is strange to find such large, young primordial galaxies. This discovery may require us to revise and rewrite textbooks on the beginning of the universe. The James Webb Telescope findings challenge what we thought we knew about the Big Bang, leaving scientists at a crossroads. Despite this, NASA recently tweeted about a galaxy cluster that lies just 650 million years after the Big Bang, adding another intriguing piece to the puzzle. Astronomers have analyzed the data and concluded that this fledgling cluster is expected to grow in size and become something similar to the colossal A1656 cluster. The place where all this is taking place is unique and special, as it is in an area of accelerating galactic evolution thanks to the James Webb Telescope. Now researchers can measure the velocity of these 7 galaxies, which gives them the confidence to confirm that they are bound together in a proto-cluster. To put this in perspective, NASA scientists compared these distant galaxies to small drops of water in different rivers that will eventually join together to form a large and powerful river. Clearly, what we once believed about the Big Bang is not adding up as expected. However, more data from the Webb telescope may reveal evidence that could confirm or disprove the theory. Who knows, maybe the Big Bang did happen, but what caused it is a different story. In any case, we will have to wait for more discoveries, but the answer may be closer than we think. What do you think about the discoveries? Share your thoughts in the comments box, and I'll see you in the next video.